Let's say this looks like a routine question. It says that you have a circle S that passes through this point and is orthogonal to the given two circles. Then they're looking for radius and the center of the circle S. Then now what? There are only two things you need to know, right? Said one is how does the general equation of a circle looks like? Let's say my circle S is looking like this: x squared plus y squared plus 2gx. That's the general equation of a circle, you know already. Okay, and you should also know that what are the things here. For instance, what is the center here? If I talk about the center, it's minus g and minus f. And what's the radius here? Yes, you know that g squared plus f squared minus c. That's the radius. Okay, now we are going to assume that this is my circle. Now it is passing through this point. What does that mean? That the circle should satisfy that, right? So I'm going to, instead of x, I'm going to put 0, and instead of y, I'm going to put a 1. Okay, so let's do that. Times 0 plus y, I'm putting a 1 plus c is equal to 0. So I get a relation. What is that? That 2f plus c plus 1 is equal to 0. That's one equation which is going to help me to find out what is f, c, and g also, with the other two things. It's saying that it is orthogonal to this circle. So the other thing which we need to know is what is the condition that the two circles are orthogonal. Okay, the condition you might have seen is this: g1 g2 plus f1 f2 twice of this, that is equal to c1 plus c2. Not difficult to prove actually, but let's use this. Okay, now the second circle, what is G and F for the second circle? Let's write it in open form. Like I'm doing a square now, x squared plus y squared. From the first bracket, you get minus 2x and plus 1 as well. But then you do a minus 16, so you get a minus 15 is equal to 0. That's the first circle. Okay, now what is G and what is F here? The coefficient, right? So the g1 is minus 1 and f1, you see that there is no coefficient of y, so f1 is 0, and c1 is minus 15 here. Okay, now let's apply the condition of orthogonality. Okay, for my given circle it is just g, f, and c. Okay, so g1, okay, my g and g1 is minus 1 plus f, f1, f, and then f1 is 0 from here. Twice of that is equal to c1 plus c2, c minus 15. So the other equation you got is negative 2g is equal to c minus 15. Let's keep as such like this. Just that you have to look for the third one. Okay, so the third circle looks like this. Here it's very simple that your g and f everyone is 0. Just that you have to pull that one the other side. So your c is negative 1. Okay, again put the orthogonality condition. Okay, g, okay, g is 0 times g plus again 0 times f, because g, f, and c are for this circle, and I'm going to use orthogonality with this one. Okay, twice of that is equal to c1 plus c2. So in this case my c1 is 1, okay, and my c2 is just c. Okay, so plus c. C is minus 1, right? Yeah, so minus 1. So this is my third equation. Now, quite obvious, right? From third equation, you're already getting that your C is 1. Yeah, this whole thing is 0. This whole thing is 0. So you're getting C is 1. So you plug in back here. C is 1, then what is your G? Minus 2G is equal to C minus 15. So C is 1, so you're getting minus 14. So your G is 7. Okay, you got your G to be 7. Similarly, you can get your F from here again. So 2F plus C you said is 1 plus 1 is 0. So your F is negative 1. So what's the center? We said, right? Negative G, negative F is the center. So negative 7 and 1 is your center. So this option is correct. That's the center. And how do we get the radius? Yeah, we said that this is the formula we might want to use. So G square, that's 49, plus F square, that's 1, and then minus C. Okay, C value also we got to be 1. Okay, these are the three values which you want to need. Okay, and what is that? 1 gets cancelled and you get the radius to be 7. A routine question, okay, nothing very tricky here. So this is your answer. Okay, this whole series is completed, and I will see you with another kind of question soon.